Okay, number 7 in chapter 27. So we have this radio transmitter. So here we'll draw a building like this. You got this radio transmitter here on top of the building. It's sending out these waves. Let's make those waves look a little nicer. So here are these nice waves like that, transverse. Okay, that has a power output. So we're given the power output of this transmitter as 150 kilowatt. Kilo's 1,000, so that's going to be 150,000 watts. Then we can eliminate the kilo. Now let's just write this one other way. Look, remember, hey, what is a watt? A watt is a joule per second. That's key here. Now this question is basically, in my opinion, it's a dimensional analysis question. This is a dimensional, remember in chemistry, like just setting the problem up so the units cancel the way you want them to cancel? So power is in units of joules per second. Now, we have the frequency of this radiation, of these waves coming off the transmitter. The frequency is 99.7 megahertz. Now, what is mega? Mega is 10 to the 6. So we can just write this frequency. The frequency is going to be 9.97 times 10 to the 7th hertz. Now, let's focus on one photon of this radiation here. One photon. Can we calculate the energy of a single photon in that wave? E equals hf. Now, if you pull out your College Board equation sheet, there is a version of Planck's constant that uses joules, and then there's a version that uses electron volts. Which one should we use for this case? We want to be in joules because this is joules, right? Power uses joules. A watt is a joule per second. So the joule version of Planck's constant, which you don't have to memorize because you'll have it on the equation sheet, it is 6.63 times 10 to the negative 34 joule dot second. And then we multiply by our frequency, which is 9.97 times 10 to the 7th hertz. Now, I don't know if you realize this. What's a hertz? 1 over a second. You guys are smart. So instead of hertz, we could just go, like 1 over second like that. And then the seconds cancel. And we're left with the energy of a single photon in joules, which is 6.61 times 10 to the negative 26 joules. And that's joules per photon, for every single photon. One photon has that much energy. So we're now ready to solve the problem. What they want us to do, they want us to find photons per second. Do we have enough info to find photons per second? Yes, we do. So we want seconds to stay in the denominator, right? So don't flip this, right? Don't flip that. We want seconds in the denominator. So we're going to go 150,000 joules per second, like that. And we're going to set up a dimensional analysis conversion like this. Now, what do we want to cancel? We're going to now take this, and we're going to plug this in. But what do we have to do? Flip it. So we're going to put joules on the bottom, photon on the top. Every one photon has how much energy? 6.61 times 10 to the negative 26. And now the joules cancel, and we get 2.27 times 10 to the 30th photons per second.